record.
So there should be controls. Oh, there you go.
Yeah, I think it is recording now.
Yep.
I hope so.
Perfect.
Okay, so I wanted to set the stage on what I'll be showing today. This is mainly to demonstrate how we will use the API gateway to connect to our API, worldwide API. Okay, there are many ways in which you can use the Amazon API gateway to connect to APIs, and it depends on how the API is deployed. So this diagram you're familiar with, I'm just going to use this diagram to show what the different components are, and I have this set up exactly the way you see it, except since NAT gateway charges by the hour, I created the NAT gateway mainly to install software on my EC2 instance, and once I did it, I deleted the NAT gateway. But what I'm showing here is, if you look at this diagram, I'll make it a little larger, full screen. You can see this, correct?
Yep.
Okay, I have created a VPC in US East region, and in this VPC, I have created two subnets, a public subnet and a private subnet. In the public subnet, I have a bastion host, mainly so that I can do an SSH to my EC2 instance, which is there on the private subnet. Okay. And I initially had a NAT gateway, which I installed. And the reason why we have a NAT gateway is so that your instance in the private subnet can access the internet in case if it needs to download, if you want to do a yum install, etc. Right? On the EC2 instance, the private subnet, it needs access to internet, and that is provided by your NAT gateway.
Doesn't the NAT gateway go on the private subnet?
No. NAT gateway needs access to the internet, so it has to be in the public subnet.
Okay, I see.
Okay, so NAT gateway is the one that gives you connection to the internet gateway.
Yep.
Because if you look at it, each subnet has a route table, which I've shown here, right? The public subnet has a route table, and the private subnet also has a route table.
Yeah.
If the route table has an entry, the target to internet gateway, it makes that subnet a public subnet. That is how you distinguish whether a subnet is private or public. You just go to the route table of that particular subnet and see whether it has an entry or a connection path to the internet gateway. Okay, fine. So then what we have, what I also have is a network load balancer. This is, when you set up a network load balancer, you can either set it up in one of two ways, either client facing or internet facing, or an internal load balancer, network load balancer. Here, I have set up this network load balancer as an internal load balancer, which means that you cannot access this network load balancer from the internet. Okay, it is not client facing. Now, I will go over some of these other elements. I have a AWS private link, which is essentially a private connection from your API gateway to the network load balancer. This is required anytime you are accessing API that have been deployed inside a VPC. So when you have API, in our case, our API are all running inside this container, right? This is where our all our services are running. So whenever you have services running inside of a VPC, for API gateway to access that API, it has to go through a network load balancer. You need to create a private link. When I say private link, what exactly it means in AWS terminology is it will be a direct connection. It will use the AWS networking, the backplane. It won't be going through the internet. Okay, so this makes it very efficient to connect to the services. Okay, I will very quickly show all these components on my AWS console. What I have done in this demo is I have deployed a dummy API service. I have created a simple Golang service which is running in this container. Okay, which it has two endpoints. And I will show how you will set up all these components. What are the security groups, etc. What is the network load balancer? I have my service running in container is running on port 3001. How do I set up the network load balancer? How do I set up this private link to connect my API gateway to the network load balancer? How I am going to define my API in API gateway, because there are different options you can use in API gateway. Once I do this, I will also not demonstrate, but at least give, because I haven't gotten to that point yet. And this is where I will need some help from Seema. Is number one, you can use, but I've seen how it can be done, is how you can implement a token generator, JWT token generator, through a Lambda function, or we can use we have currently an existing endpoint that generates JWT token. That's correct, right, Seema? Okay.
Yes, that's right. That's right.
So we can leverage the same endpoint through the API gateway to generate the token. Once the token is generated, whenever the client calls a particular API, we need to validate that call by using the JWT token, right? Whether it is a valid token or not for that particular API. That can be, in API gateway, there is something called a custom authorizer, which can be implemented as a Lambda function, which will validate the function of that authorizer will be to validate the JWT token for that particular API method. So we can have really very fine-grained authorization at a method level, at what operations the client can perform on that method. So I'll jump straight to the demo. Any questions on this diagram?
So the network load balancer is connected to through the API gateway through the private link.
That is correct.
Then what is the purpose of the internet gateway? The
internet gateway, we are not using the internet gateway for the API gateway to talk to our this thing. It will be going through the network load balancer. But when you have egress traffic, let's say that you are going to, for that it will go through NAT gateway to internet gateway. If our container is going to, if some component inside our container is talking to the external world, let's say even for submitting a transaction to Stellar, you will be going through the NAT gateway to internet gateway.
Why don't we want to go through any sort of private link for that? Why is that? No,
see, you can't create a private link to Stellar, right?
Okay, I see. Yeah, that makes sense. Okay, because this
requires. However, you're absolutely right. If we want to talk to participant registry, for example. Private link only if the component is also running on AWS on a VPC.
Okay. So if we have control of that component,
we have control of that component. If our participant registry, for some reason we decide to deploy our participant registry in the IBM cloud, right?
Yep.
Then to access it, you'll go through the internet gateway. You can't use a private link.
Okay, I see.
Clear?
Yep.
Okay, guys. So let me now move to the console. And I have many tabs. I have 1, 2, 3, 4, 5 tabs. So I'll start with this tab. The first tab. So I have my own AWS account, in which I'll first show you. I have created a VPC called www-vpc.p1-p1. It is running in region North Virginia, US East 1. Okay. And in this VPC, and the CIDR block for this VPC is 10.1.0.0/16. Okay. And then I have 2 subnets that I have created in this VPC. One is a public subnet and a private subnet. Okay. Both of them are in the same VPC. And as you know, the subnet, the VPC will span the region, right? If you look at the diagram, this is, I know you're 100% familiar with this, Daniel, but just as an FYI, this is the VPC, and the VPC will span all the availability zones within that particular region. So VPC is a regional construct, whereas a subnet is a availability zone construct. Subnet can span only a single availability zone. So if I go back to...
So if you want to have redundancy across multiple availability zones, that requires multiple subnets?
Yes. So what you'll do is you'll just, if you want multiple subnets, okay, what you will do is do this one, same VPC, okay? So your VPC will go like that. You will have one subnet, one availability zone here. So you copy and create a second, you don't create an availability zone. You go to the second availability zone. So this is 1A is availability zone, the first availability zone. So you'll do the same thing for US East 1B, the second availability zone. You'll create a public subnet and a private subnet there.
Okay.
Okay.
And now what about the network load balancer?
Network load balancer now will load balance. In this particular example, I have only one subnet in one availability zone. So it is not really load balancing across two availability zones. When you create a network load balancer, you will attach the availability zones, which availability zones you are at, or the subnets you are attaching. I'll show it to you, for example. Okay. In our example, we have only a single subnet in a single availability zone. So the only thing it can load balance is if I have multiple containers in the same subnet, it can load balance across the different containers.
Okay. In our case, when we plan to deploy multiple participants onto the same EC2 instance,
which you don't want to do, because I don't recommend. See, if you put it in the same EC2 instance, then you are essentially putting all the participants in the same VPC.
That's what I'm thinking, right? There's no way to have them on the same instance and still maintain VPC segregation.
You cannot do that. The only thing that you can do is, see, if you're okay with putting all participants in the same VPC, which I advise against, because the way I look at a VPC is something that is private to a participant.
Yeah, no, definitely.
And so if you go with that, then you cannot do it. You can probably get away with it in a sandbox this thing, but I would say what is the cost? You can use, if you want to do it in a sandbox, then at least one thing you can do is you can put it in the same EC2 instance, but put it in different subnets. What I mean by that is EC2 instance can have multiple virtual interfaces, VIF, right? So you can, and the VIF for the same instance can be in different subnets.
Okay, so in this case right here, we have container one, which we're going to say is the participants node, their service node, right? Now, in theory, we could create a second private subnet in the same availability zone. So there's two private subnets in this zone.
Yes.
Just split like the CIDR block into half and give one half to one half to the other.
Yes.
And now, and it's possible for us to restrict communication between those subnets?
Yes, you can. See, what you will do is, in that particular case, you can, if you have advanced networking knowledge, you will know what we are referring to. And I don't, but I know how it can be done. The same instance can have multiple VIFs, okay? Virtual interfaces. And you can have the VIFs in different subnets. You can have, for the same instance, you can have one VIF in subnet 1 and the other VIF in subnet 2. In VIF 1, you can have participant 1 instance running, and VIF 2, you can have participant 2 instance running. So essentially, you're having the same instance, but a participant running in different subnets, private subnets.
Okay.
In that particular case, that the load balancer, instead of pointing to the instance, it will point to the interface, the VIF.
Yeah.
Elastic Network Interface.
Yeah.
Yeah.
So in that case, we would be able to stack multiple next to each other then. You
can, but it, we have, and for that, I think you really need, if for troubleshooting and making it correct, you really need an advanced networking engineer to help you with that.
Okay.
We can do it, but you'll need some additional expertise in that. But to keep it cleaner, let's go with multiple VPCs. If a cost is, I don't think the cost is going to be that much here. Anyway, we are going to build a client, right? Charge them for anyhow. Anything else in this diagram before, because I don't have too much time to go over this.
No.
Okay, so let me go to the screen. So I said I have a VPC with two subnets, a public and a private. Okay, and then I will show you the instances. I have two instances. One is P1 private, which is running in my private subnet, and then P1 public, which is an instance that is running in the public subnet. Okay, so these are the two instances I have running. And then what I also wanted to show is I have a load balancer, network load balancer. Let me see where. Okay, load balancers, network load balancer. See, this is a private network load balancer, not because I call it private. It is a private load balancer because it's internal. The scheme is internal. Okay.
Yeah.
So if you want to create a new load balancer, for example, I'll just not go through the entire step. I say create, and then you will specify whether it's internet facing or internal.
Okay, I see. Okay.
Okay. So I'm doing internal. And then what you would do is, let me go through this very quickly. You'll be, since it's a network load balancer, you'll choose a TCP protocol 80. And if you want to do 443, then you can also do that. Add additional listener. This is the protocol in which it is listening to client requests. So it is listening to client requests on port 80. Okay. Mm-hmm. Then you specify the availability zone where you want this network load balance, not the availability zone, the VPC. So you'll say WW, this is the VPC I have, right? And in this VPC, I have, since it's a private, I have only a single subnet. Okay, sorry, US East 1A is the availability zone. Now I specify the subnets that I want to associate with it. Okay, so I will choose this one. If I had multiple private subnets like in availability zone 1 and availability zone 2, then I'll specify both. Okay. So then what you do is next you configure the routing. Now here what you're going to do is, okay, now what is the load balancer protocol that I want to use to talk to my backend EC2 instances? So that one is again TCP, and I said 3001. This is where my services are listening on my EC2 instance. Oh, did I change it? No, I did something wrong. Okay. No, not this one. Yeah, you need to specify a name. Say, sorry.
And then
next is configure routing. And then I say create a target group, new target group. This is my target EC2 instances. So I say test or whatever, target group, and the protocol, and this is where I specify the port 301. Here I can say instance or an IP address. Mm-hmm. Okay, and then health checks, etc. And then next register targets. This is where it will tell me, okay, you have these two instances running in private and public. These are my EC2 instances. So I register my targets, etc. And then I can say I had registered, and then next review. Okay. And then I'll create. So this will create my network load balancer.
I see. Okay.
Okay. So I'll cancel out of it, which I have already done here. Okay. So I have gone through this. Now, what I will do is I will go to my terminal. I'm first going to connect to my public EC2 instance. Okay, I already have a certificate created, and I've registered my certificate in the SSH agent. Now I'm connecting to the private EC2 instance, which is here, this one. Sorry. This public EC2 instance. So if you look at it, the IP address of the EC2 instance, since it's public, it is 34,235, right? So I'm going to go there and connect to that public instance. Okay, so I've already connected. And then from there, I'm going to SSH to my private instance.
These muscles don't just grow between.
So the private instance, it doesn't have a public IP address, so I have to connect to its private IP. So now I am sitting in the private instance, which is the instance that you see here. Now I'm sitting in this instance, correct?
Yep.
Now here, I've already, if you look at I have a folder called projects. So see, I've already installed Golang here, but what you guys will have is you would have installed your Docker container image here, right?
Yeah.
So I am going to run this app. I have a simple app called app.go, which has two HTTP endpoints. Okay, so now this service is running, and it is running on listening on port 3001.
Yeah.
Okay, now I will go back to my to API Gateway. Okay, so in API Gateway, I will need to create a VPC link, right? First, I need to create a VPC link. So I already have created my VPC link, which is connected to this private network load balancer. But what you would do is just very straightforward. You specify a name for the VPC link, description, and then you specify the load balancer. It will automatically show in the dropdown. Do you see that?
Yep.
Yeah, so this is a private load balancer, and you create the VPC link. That's how you create. I'll cancel out of this. Okay. Now, what I have is I've already created a API in the API gateway, but I will just very quickly show what you would do to create an API. So I go to API, create API. So here you can import a Swagger file that you already have. That is the import from Swagger or Open API. So if you already have a Swagger file, you can import it, or you can create a new API from scratch. Okay, clone an existing API, etc. So I'm just going to. Now the endpoint can be either regional or it could be edge optimized, because what Amazon has is it has API gateways, just like your CloudFront. It has edge optimized API gateways so that it is easy for a client to connect to this API. Or you can have a regional API. We are going to have regional API because we have APIs deployed in a single region. Okay, so I'll very quickly run through this. So I've created an API called test API. Then what I do is I create resources. Resources are going to be like, for example, let's say, there is an option here called proxy. I will show that later, but this is how you create a resource. This is nothing but your URL path, right? We are all familiar with how REST API works. So I have created a resource, for example, called participant. And then for this participant, I create the methods. The methods are going to be your different HTTP methods. For example, get, okay? When you create a get method, then you specify, this is where you specify, okay, how is this particular endpoint implemented? Because this is going to correspond to this particular resource, this particular get method, which will have a handler method, right? You can implement this endpoint using a Lambda function. You can implement this endpoint as an HTTP endpoint, which already exists, a mock endpoint or a different AWS service. In our case, we'll be using VPC link, because our endpoint is running inside a VPC on a EC2 instance. Okay. Use proxy integration means that whatever you're not going to do any transformation of the request that you're receiving from the client to the request that is being sent to your endpoint. Okay, if you are doing any request translation or a response translation, then you won't use proxy integration. Okay, so here again, this will be a get method. Your VPC link, what you will do here is you specify the link that you already have, or you can use a stage variable and specify its stage. I'll show exactly, I don't remember the syntax here. I'll show exactly what this is when I show my actual endpoint. Now here is going to be the endpoint URL of your service, and this is where again the definition was not very clear. It can be anything. It is a dummy URL, so you can put anything here. www.dummy.com. Okay.
Mm-hmm.
What is this? Okay. I'm approaching my limit. What did I do? Okay. So I'll do a save. Here, I need to, I don't think it will let me save unless I do this. So I do a save. Okay. So let me go to my VPC link. This is what I had created, an API called VPC link. Now, here I am using proxy. What this means is we don't have to, but in my case, for simplicity, I'm using a proxy. Proxy means you don't need to specify all your API endpoints in the API gateway. You just call it as a proxy endpoint, okay? And the method will be any. If it is proxy, then the method will be any. What it means is anything that hits this API gateway will be going to the endpoint, will be going to your VPC link endpoint. I'll just show what it looks like here. So this is, if you look at it, this is the method request that is coming here. And then this is the integration request. So this is client facing, right? This is where your API gateway receives the request. And this is the integration request is what actually is sent to the endpoint. And that is done through a VPC proxy.
I see. Cool.
Okay. Because we are running out of time, I'll just very quickly, because this is important, but I will probably schedule another time. So this is the method request. And here is where, okay, let me go back. You can test this one here itself. Let me see if I can test this. Okay, I need to get the VPC link. So it gives me a response, hello world. So it has hit my, so what this has done is it has gone all the way from my API gateway through the private link, hit the network load balancer, and it hit the service endpoint in the container and returned the response. So that is what, and I have another endpoint, the same one called goodbye. Okay, so let me just very briefly show what it will look like. Let me recreate this. Sorry. By the way, you can also set the enable API gateway course here. But what I wanted to show was, okay, so if you look at this VPC link, this is my API, right? Under API, you have authorizers. You can create a custom new authorizer, and you can specify a Lambda function. You specify the name of the authorizer, the Lambda function, and the name of the Lambda function that you have created. Okay, and so this is where Seema, for example, when you want to do JSON Web Token validation for any request that's coming, you specify the authorizer. So before that API gets called, this authorizer gets invoked, where you do the token validation and then determine whether that API can be called or not.
Okay.
Okay.
So in that case, how would the authentication, like the IBM ID, right? That integration, how will that work for this scenario?
So see, okay, for example, today you're doing, how are you doing web token validation? When the user calls
Right.
an API with JSON Web Token, right? So it
Yeah.
comes and hits you, and you are inside the code, you're validating the token. Are you using the IBM?
No, not yet. IBM ID integration is not done yet. Okay. But I'm just trying to understand from the architecture point of view where this will fit.
See, IBM ID is sitting outside, right? So if you're however you are planning to implement that authentication of the web token, you'll put the exact same code. You can implement in Golang. If you're going to call IBM ID from your Golang code, you'll do exactly the same. You're not going to do anything different.
Okay.
It only thing is it is going to be implemented as a Lambda function, and the Lambda function could be implemented as Go or Node.js or whatever. And you will put the same logic for validating the JWT token, whatever you are planning to do. If you are going to use IBM ID, then I don't know what the API or call to IBM ID will be, but you'll be doing the
same. Yeah, the validation, like there is this RSA key, and that is unique for each participant, right? Sure. So if you are using a Lambda function, like how do we do that part? That's because it's different for every participant.
No,
I mean, is this gateway be unique for a participant?
Yeah. Yes, you will have this Lambda function that is unique, because this Lambda function, see, here you are going to specify the name of the Lambda function. Okay, you are not defining the Lambda function here. You'll go to the Lambda function console. You can specify that this particular Lambda function that you're going to define will be running in a particular VPC in an availability zone. Okay.
Okay.
And so that Lambda function that you will have, it will have its environment variables. The function is going to be the same. The function itself won't differ from participant 1 to participant.
What we have.
Okay.
Oh, the function will be the same, but the environment variables can differ.
Exactly. So when you create a Lambda function, let me 1 second. So before I go to that, Seema, the token, the first thing before you even do validate a token, you have to generate the token, correct?
Yes, that's right.
You'll have an endpoint, and for that you can just have another endpoint, just like we have the endpoints here. You'll have a token generation endpoint, right? Which is what you currently have. And that token generation endpoint is going to take in some client credentials like user ID, password, or whatever it is. Correct?
Yeah.
What are we doing today? You're probably what client credentials are you using to generate the token?
See, the thing is, right now, I mean, we have done some mock implementation, right? Like we are using the account name and the token, the auth token, as something that we randomly generated. But ideally, we have to use that two-factor authentication, right?
Fine. So,
in order to first authenticate and then.
Yes, we have not implemented that yet. Whatever we currently have implemented is exposed as an endpoint, correct?
It is. Yeah. Yeah.
Okay, so even now what you will do is you'll call that endpoint to generate the token, and then when you call the API, you will pass the token, and your Lambda authorizer, which I just showed you, will validate whether the token is authorized or not. And you'll be using the RSA key wherever it is stored. I don't know how IBM Connect comes into the picture during authorization, because all you need is to look at the RSA key to validate that particular token, and once you validate it, you look at the access privileges inside the token payload to determine whether he has access to this particular method or not.
Fine. Okay. So this is the whole idea behind this is we can use the same function, and then basically we can use different microservices. So basically all it is a mapping of different microservices endpoints to different containers, right?
Yes.
Is that what I'm understanding here? Like exactly. For example, API service, and then we will have separate code service. Right? So there's going to be the same Lambda function in here. Only thing is like different API URL path will go to different EC2 instances.
That is correct. So before you are absolutely right. So one thing I just wanted to quickly go over, depending on where I have. Everything is easy to manage. Okay, Seema. So this is I'm to create a Go function, a Lambda function. That is where I am. The function is called zip. You can upload the Go file into this one, as a zip file wherever you have your Golang function written. Okay, and then you can specify for that function the environment variables. Execution mode, tags, settings. You specify which VPC it is coming. I don't see it here, but I think once you can specify the environment variables for this particular function. Just like today for our Go function, we specify the environment variables, you specify it here. Okay.
So two questions I have. The first one is, do we need Shannon to look at this? And, I mean, what do we have to do to make a decision on this, number one? And number two, I think Stan said he wanted us to look at IBM's API Gateway because it was supposedly platform or cloud agnostic, right?
Yes.
And I think he also mentioned towards in the same call when we discussed this, but for right now, we'll go with the AWS API Gateway. If we plan to do this by GA, if we bring in an external API Gateway from, say, IBM or whoever it is, we are not going to do this. Just one more thing I wanted to mention, the same thing. You specify stages also when you deploy, whether it's a development stage or etc. And so what I have here is this is the URL that I can type into the browser to call my API. However, you can also specify custom domain names for this API. So you can create a custom domain name so that you have an API which is like worldwire.mbank.io, for example, or mbank.worldwire.io to call that API. There is a lot more to what you can do in API Gateway. And I will, for example, just copy this URL and go to a browser.
My question, I do have one question about the DevOps role here. I do see that this is like very custom configuration on AWS, right? And we'll have to always repeat this for every participant.
Everything that we have seen, Seema, will be automated through CloudFormation. I am going it through a manual console process. Everything that's setting up the network load balancer, setting up the VPC link, everything that we have seen, setting up configuring the API gateway, they'll all be automated through CloudFormation.
Okay, in that case, that's excellent. Yeah.
So if I say, no, nothing here is, I'm showing it here. See, so this is how it will work, right? You're going to use that API gateway provider URL, which can be replaced with a custom domain name, and you're calling it, and you're now the only thing that I still have not, from an architecture point of view, figured out yet how it will work is if I go back to the diagram very quickly. See, what I have shown here is a request coming from outside, hitting the API gateway. The API gateway will do the JSON token validation. You can also put a certificate here so that you can have a certificate that a client participant is going to provide for authentication. Then the traffic goes via the private link to the load balancer and hits a container. Now, in our case, it doesn't end there, right? Now, this is going to call another service either within this container, which will not be a problem. But it will also potentially call a service for a different participant. So for the path for that will be through the NAT gateway to the internet gateway, and it will hit the API gateway again before it talks to the other participants' API. Okay, so we need to just make sure that we have set it up properly so that all communications, not only within a single participant, but between participants are also facilitated through the API gateway. Questions?
Yeah, so when we are calling other participants API service, right? Like, I mean, we haven't thought about, that part yet.
No, see, what we are doing today, Seema, is because we are putting everything in the same VPC, in the same instance, okay? We are actually not realizing that some of the challenges that we will have when we separate these nodes, okay, and how these nodes will communicate with each other. Okay, so we will, the minute we move this to broad net where we are going to deploy each participant node in a separate VPC, if we don't figure out how this communication between participants is going to happen, we are going to face challenges. And we need to resolve that right now by clearly drawing out all the communication paths between participants, between participant and the participant registry, between participant and the Stellar, etc., how it should really happen.
Okay. Yeah. I think this is a good solution for us to on the way towards the independent microservices.
No, not just independent microservices. Okay, I think whether we are, even if we go with exactly what we have today, okay, and nothing different. Let's say that we are going with our API service, which is a front or a facade for all other services. Okay, by doing what we are doing now, it's not mainly to address the independent microservices. It is mainly is the connectivity going to happen through the VPN, or is it going to come through the API gateway?
Oh yeah, that is also one more point.
No, that is the main thing that we are looking at. How are you accessing the API? Are you accessing the API through the VPN gateway, or are you accessing the API through the API gateway? That is what we are trying to solve here.
Yes, right.
And not only that, by moving the security, the token generation, etc., we do not want our business code to commingle with the security authentication code at all. We want to completely decouple all the security enforcement outside of our business logic.
Excellent point. Yeah.
Okay. Because today, otherwise we'll be adding, if you look at your API service today, right? You have all the JWT validations, everything happen. It should not be there at all. It should be, we should look at it as an aspect-oriented cross-cutting concern. Security is a cross-cutting concern. It should not be with our business logic. And that is where you have this custom authorization module, which will intercept the API request, do the security validation before passing the request to your service.
Okay. Yeah. I think I'm good with this, and if we can avoid VPN setup, that is really complicated, right? So, what is your point of view on this, Chase?
I think that well, I think it's I'm okay with it. I'm a little bit. I want to make sure that we run it past Stan and Shannon, because I don't want us to do a whole bunch of work and then I don't think we're going to raise a red flag, but just in case, I
agree.
Do a lot of work and then
I agree.
Yeah.
I agree. Yes, for sure. So, Sudhakar, will you be taking this with Stanley and Shannon,
Yes.
and so that we can go ahead and
absolutely. The idea for this particular call is for me to just show how it will work, because as developers and as from Daniel, I'm not saying that you're a DevOps guy, but since you have taken ownership on automating this entire infrastructure deployment, wanted to give you a taste of the components and what is involved.
Yeah, no, definitely. It was definitely very helpful. And I mean, it looks like a pretty solid architecture, honestly. I mean, I don't see any issues with this, especially if we can still, I think the main thing that I'm trying to wrap my head around now and try to digest is how to automate this, the setup of this whole process. Because when we add people on and we assign them to their own private subnets and spin up their containers, that has to be automated, and that load balancer that has to ideally also be able to spin up more and more instances as needed to handle the load. And I'm not quite sure exactly at the moment how to wrap my head around all of that and get all of that to kind of work synergetically together. But I plan to review this video and look into it more. And I'm sure I'll be reaching out to you, Sudhakar, quite a bit going forward, just to keep ask questions and get more clarification.
Okay, and I think we need to draw a line in the sand when it comes to we should not be putting all the participants the same VPC in the same subnet in the same EC2 instance. We will unnecessarily complicate things. We should, when you create a CloudFormation template, your template, especially when it comes to a participant node, it should be for a single participant, which you will create multiple stacks for each participant. But as you don't put all participants in a single CloudFormation template.
Okay, sure. Then,
which means that each template. I'm sorry. Each participant node CloudFormation template, they'll be identical. They're not going to be different except for the parameters, which will say what VPC ID, etc. Right? Or what this thing. And here they can have because they can have the same CIDR block range also, because they are not going to do peer them. Okay.
Yeah.
The one last thing is what I wanted to say, I forgot. I'm sorry. Go ahead.
How will Docker Swarm kind of play? Into this?
It works very well, right? I'll show you. What I wanted to say. Let me go back to the share mode. We are almost running into the other. Oh, we are running. Let's continue this later.
Already. Yeah, let's continue. We need one more session now.